Good afternoon, everyone. I'm David Hahn, the Craig M. Birch Dean of the College of Engineering, and I'd like to welcome everyone to our final webinar for our Spring 2022 Alumni Faculty Lecture Series. Our goal does remain the same. It's to share discussions on important topics and have a Q&A with our guests and our alumni and friends, including many who generously support this college and have really helped to make this happen. I often talk about the most significant challenges that face society, including food and water, energy, healthcare, and security. And today we're addressing energy. And I'm delighted to be joined by two powerhouse alumni of our college, who through their combined leadership provide a vast amount of the reliable energy and water needed for the citizens of Arizona. A few basic facts. The people of Arizona consume about 110 terawatt hours of electrical energy per year, which by my calculation, mechanical engineer, is the equivalent to the energy contained in about 1,000 tanker trucks of gasoline per day. Think about that. That's a lot of energy. Yet when we flip our light switches, it's a very rare day in Tucson or Phoenix that the light doesn't come on. And I'll note that both companies have among the highest reliability in the nation. I'd like to introduce our panelists now. Susan Gray is President and CEO of Tucson Electric Power and UNS Energy Corporation. Susan has worked her way up from the bottom, starting as a Tucson Electric Power student engineer while studying electrical engineering. She earned her BS degree from us in 1996, stayed with TEP, and later became a double wildcat when she obtained an MBA from the Eller College of Management. Now she ensures safe and reliable distribution of energy to more than 650,000 Arizona customers. Susan encourages inclusivity and diversity of thought on her team and strongly supports STEM education and programs for girls and women. She serves on the advisory board for the College of Engineering. We're very proud of that. The Eller College, two professional association boards, and the board of the directors for the Boys and Girls Clubs of Tucson. She's also a triathlete. Welcome, Susan.
Thanks, Steve.
It's my pleasure also to welcome our second panelist, Mike Hummel, is General Manager and Chief Executive Officer of Salt River Project. Mike has almost 40 years tenure at Salt River Project, serving in several executive leadership positions, and was named SRP's General Manager and CEO in 2018. He also holds a BS in electrical engineering from us and an MBA from Arizona State University. He's a registered professional engineer in Arizona and Nevada, and has also successfully completed the MIT Nuclear Reactor Technology Program, which is probably a good thing when you own part of a nuclear power plant. Mike is an active leader on professional, technical, and community boards, including the board of directors for Teach for America, the Electric Power Research Institute, the Greater Phoenix Chamber, and the Greater Phoenix Leadership Council, the Large Public Power Council, and the Nuclear Electric Insurance Limited Council. Mike is married to Sherry, and both their sons, Ryan and Kevin, are also UA Wildcats. Welcome, Mike.
Good afternoon, David. Thank you.
Glad. The College of Engineering is very proud to have such distinguished Wildcat engineers leading energy solutions for the state of Arizona. So again, I'm really glad you could join us for this conversation. Before we get started with the Q&A, Susan and Mike will present just a few slides to help set the stage today. Susan will talk about some of the challenges of running an energy company. Mike will speak to the issues related to changes in the utility model, long-term versus short-term decisions, and both will share their thoughts on balancing reliability, sustainability, and affordability. Before we get started with your slides, just a quick fun fact for both of you. We'll go from Susan and then to Mike. Susan.
All right, this is fun to share. So I always say I was the little brother my brother never had. So he raised me to be an athlete and taught me how. I didn't like to just watch sports. I like to play sports. So he taught me how to throw a football. And I ended up marrying a football player who said that it was love at first sight when he saw me throw a spiral.
Fantastic. Thank you, Susan. Mike.
Well, my sports history is a little different. I actually received a wrestling scholarship to go to U of A. That's how I started. And I was fortunate that they canceled the program before the freshman year started. So I never had to wrestle when I got there. And it was probably the best thing that ever happened to me.
Fantastic. Good job. Well, I appreciate you sharing a little bit on the personal side. Now you wrestle electrons for a living, right, Mike?
Yeah.
So Susan, I'm going to let you start off and share your screen and kind of set the stage for this.
All right. Thank you. Well, TEP is a regulated utility, just like SRP, and we've always had to balance our obligations to provide safe, reliable, and affordable service to our customers. And as we plan for a sustainable future as a nation and in the world, we know we're an important part of that equation, and that we're deeply involved in reducing carbon emissions and mitigating the effects of climate change. So how we balance all of those interests is really the key challenge that I face as a utility CEO. But the good news is that long-term planning is our bread and butter. So utilities are well suited to help lead this transformation. I'm proud to say that we have a long history of service to our customers and communities. And a lot has changed since 1892. Back then, we actually powered the grid by burning mesquite wood. And now our generation mix, of course, includes both conventional fossil generation and also utility scale solar and wind. And as the technology's changed, our rates they're actually lower today than they were more than 100 years ago, if you can believe that. Just a side note, many of you have heard of the Fortis Inc., and it's a Canadian-based company that purchased UNS back in 2014. And so we get to be part of this family of utilities. Fortis has 10 gas and electric companies spread across North America. So this slide just gives an overview of both our service territory and also our key generation and transmission facilities. So UNS is the umbrella company, and under that we operate 3 regulated utilities here in Arizona. Of course, TEP is the largest in terms of customers and load, but it covers a comparatively smaller geographic footprint. And then Unisource Electric provides electric service to Santa Cruz and Mojave counties. And like TEP, it's a vertically integrated company that provides generation, transmission, and distribution of electricity. And then Unisource Gas is a gas distribution company that covers most of northern Arizona, along with Santa Cruz County. And then you can see on the map, we have a mix of coal and natural gas plants, as well as solar and wind resources that are throughout both Arizona and New Mexico. So as we drive sustainability, we've developed an integrated resource plan, and I'm really proud of this plan. It's ambitious, but achievable, and really sets our goals for our clean energy future. What I'm most proud of is the process that we followed to develop this plan, where we engaged a broad range of stakeholders. And those stakeholders participated in a process where we developed a wide range of portfolio options on the spectrum, from very aggressively exiting coal as soon as possible to others that are focused on a more gradual transition. And I think the process was great because we gained the benefit of the stakeholders' perspectives, but at the same time, those stakeholders were learning about the challenges and trade-offs that are present in every one of these scenarios. So ultimately, we selected a preferred portfolio that optimally balances all of those key considerations, right? Thinking about affordability, reliability, carbon reductions, water use, and even the impact to the coal communities. So our goal here is to lower our carbon emissions by 80% by 2035. And that goal was actually developed in partnership with the University of Arizona, and it represents our fair share of the worldwide efforts to limit global warming, which is consistent with the Paris Agreement targets. So to achieve that goal, we expect 70% of our power will come from renewable resources by 2035. We had a big year last year. We actually added 450 megawatts of new wind and solar resources, and that actually doubled our renewable production in just the 1 year. So our focus, I'd say in the short term now, is on energy storage. We need to help maximize the benefit of these current renewable resources and also support the integration of even more renewables on our grid. So we're committed to this cleaner energy future, but that requires substantial investment in our system to really achieve these goals. And our integrated resource plan is designed to achieve this transition that's at a pace that our customers can afford. So we're balancing the integration of new renewables at the same time as retiring our coal resources. So, this is a very capital intensive investments in these renewable resources, but they have lower long-term O&M costs. So you think about, there's no fuel, right? Wind and solar, no fuel there, and actually takes way fewer people to operate these resources. So in the long run, we should see a reduction in costs over time. And then the timing of integrating these new renewables with the retirement of the coal plants, this allows us to really keep our rates affordable for our customers while we're ensuring our continued reliability. So as a utility, we're navigating all of these trade-offs between reliability, affordability, and sustainability. And that is just a constant balancing act. And I mentioned this earlier, but we really can't lose sight as we're trying to do all these things that there is an impact on the coal communities. If you think about, up in the White Mountains, a lot of those folks work at power plants that are owned by both Mike's company and mine. And so we want to make sure that we're navigating this transition in a way that supports the long-term health of those communities, and really honoring that they've helped power the West for decades. So I'll finish on this slide. This is our UNS values that we recently developed. And when I think about a responsible community transition, to me, the value that stands out here is that we do the right thing. And, these values are part of our DNA at UNS. And I'm really proud of, again, how we came up with these values was a really employee engaged process. But they're at the heart of everything we do. They drive my decision-making as well as my team's, and really help us as we navigate this balancing act of operating an electric grid that's affordable while at the same time maintaining that reliability. And then, of course, achieving our sustainability goals. So that's what I wanted to share. I'm looking forward to the discussion, and I'll turn it over to Mike now. Thanks.
Thank you very much, Susan, for a very informative setting of the stage. Mike, turn it over to you.
Yeah, thank you, David, and thanks to the Engineering College for putting these sessions on. I think they're terrific, and I think they give us all an opportunity to re-engage with the college. So it's a great opportunity for us.
Thank you.
So I'll talk about some of the same things that Susan addressed and a little more specific to SRP, but let me give you just a little background of what SRP is, since a number of people outside of the Phoenix area are not familiar with it. We're one of the nation's largest public power utilities. And what I mean by public power is that we don't have shareholders. We are a nonprofit, community-based organization. So any returns, any net returns SRP makes goes back into the company as opposed to going to shareholders. So it gives us the ability to have a very unique focus and a very pure mission on serving our customers. And we serve about 2 million people, both water and power. And I'll talk a bit more about that as we go on. We're the largest raw water supplier in Arizona. And that's about 800,000 acre feet of water annually, which is a significant amount. Interestingly, this community uses less water now than we did 40 years ago, even with the growth that we've seen. And that largely is due to the urbanization of Arizona. And as we've seen some of the agricultural areas begin to urbanize, you see water use go down. Clearly, that's going to end at some point, and we'll need to focus on that. And I'm glad to talk about that a bit later. It's interesting, the area we serve water is relatively small geographically. It's limited to the Phoenix area, but to get water for that many people, it takes a 13,000 square mile watershed. So it goes up into the White Mountains, over toward Flagstaff, White Mountain Indian Reservation, and all of that drains into the Salt and Verde rivers and ultimately forms the watershed that serves SRP. So when you look on the power side of the company, we have a very diverse portfolio of generation. What you'll see here is generation units spread over 5 different states, and you'll see nuclear, coal, natural gas, geothermal, solar, wind, biomass, and quite a few batteries mixed in with that as well. You can see if they show up well on the screen. And we can talk about storage if there's questions about that. If you looked at this graph just 10 years ago, really just 5 years ago, it'll look a lot different. You would have seen more coal on here, and you would have seen just a couple renewable stations. So we've got a very aggressive approach to the conversion of that that generation resource to something that looked a lot different than it did over the last 100 years. What you don't see on here are two of the largest coal plants in the Western United States, and we have shut those down over the last several years. So we're well on our way to that transition, but it's not a real easy transition when you think about operating in an area where there's high growth. So when you look at Maricopa County, we are the fastest growing county in this country, and our load is growing at about 3 times the national average. So not only do we have to replace 3,000 megawatts of coal that will be shutting down between now and the next 12 years, but we have to add about 3,400 megawatts of demand for the growth that we're going to see, both native growth and new companies moving into the area. So when you figure it all out, it comes to about 8,000 when you look at the difference in capacity of some of those units. 8,000 megawatts that we have to add to our system between now and 2035 of renewable energy. And that's a lot. That's about our total load right now. And at the same time, you're adding that, and you have to look at the dynamics of the system. And you'll see we move from an inertia-based system, a system based on large, heavy mass turbines, which provide stability, frequency response, and voltage control throughout the system with small incursions, to a solid state or an inverter-based system, which is an entirely different way to manage the system. So not only are we going through a change in the numbers and the load, but how we deliver that as well. That really is in response to a change in the entire utility model, because it's not just the generation that's changing. While we're changing that generation, it's really a fundamental change in the grid itself, on the transmission side and on the generation side. In the past, we have had producers of electricity, that's mainly the utilities, and we've had consumers of electricity, our customers. What we see now is prosumers. You may have heard that term, but we're talking about entities that both consume and generate electricity. So we have to see changes to the grid and develop changes to the grid, such as now bidirectional. And we're taking energy from a customer, maybe it's rooftop solar, maybe it's vehicle to grid, back into our system, and then a different hour of the same day, we're providing it to their system. So it's a very much a change in the dynamics of the system. So if you think about not only changing the fuel for the resource, you're also changing the communication protocols, you're changing system protection, relay protocols, you're changing all of the control engineering, you're changing how you interact with those customers. The amount of data analytics that go into that is significant. So you can see why we depend on programs like University of Arizona and other engineering programs to understand this and to be developing the talent that comes into these organizations and help us get where we're going into the future. So it's clearly, I think anyway, the most exciting time in this industry. When I came into this role, I had told my board that we would see more change in the next 10 years than we would in the last 100 years in the electric utility industry. And I don't think I'm off the mark. I think we're well on our way to that. And I think the pace of that change is going to continue to increase. And I think it's going to be people sitting in this webinar today that are going to help move us to where we need to go. We have done a lot already. We committed to adding 2,000 megawatts of solar by 2025. That is all but a couple hundred megawatts already under contract. And we're looking at another 500 in pretty short order. We have over 400 megawatts of battery storage in process right now as well. And you can see we've added wind, we've added new generation from gas turbines. We acquired an additional share of the Palo Verde nuclear generating station from Public Service in New Mexico. So we own about a quarter of that, the nuclear generating station, which is, by the way, the largest nuclear generating station in the country. and a great producer. We are expanding some gas-fired generation as well, and you might, at first thought, think that's inconsistent with the plans to move to a carbon-free renewable environment. In fact, it's just the opposite. When you add that many intermittent resources on your system, you need quick start regulating resources to be able to make that happen. And that's what the Coolidge expansion is meant to do. We also work on the customer side on demand response and upgrades to our other natural gas plants. So we've got a lot going on. And I'll just close by saying, consistent with what Susan had said, electricity you can really view as a public good and necessary and a requirement by people. And because of that, it lends itself to a monopoly environment, monopoly business environment. In exchange for that monopoly franchise, we take on the burden of balancing reliability to our customers, affordability to our customers, and moving toward a far more sustainable future. And we can't think about that in terms of one type of customer. It has to be affordable for all customers. It has to be reliable for all customers, from the Intels to a small residential service. And customers have increased demands when it comes to sustainability. So that's the burden that we take on to manage that. And it's a challenge for all of us. So David, thank you. Appreciate it and look forward to the discussion.
We appreciate the commitments of both of you to the people of the state. So I've pulled questions that have been submitted by the audience in advance. I'll pull some in real time, and we'll try to get through as many as we can. We won't be able to answer them all. So I've kind of grouped these around themes as they've been submitted, and we're going to start with renewables. We heard a lot about renewables. And as you both noted, one of the key issues with renewables is energy storage. So how do you see this being resolved? And you can also comment on technologies if you want: batteries, salt domes for compressed air, molten salt, pumped hydro. So I'll go Mike and then Susan, and give you each a chance to comment on the challenges of energy storage.
Yeah, thanks for the question. It's a great question, because storage is really what unlocks the value of those renewables. And if we're going to continue to add renewables and replace units that we have dispatch control over, we need storage in the industry. Right now, lithium-ion battery is the prevailing technology. It's not the most efficient technology out there. It's clearly some of the raw materials to support it are a challenge. They are in places of the world that can be very challenging to get supplies from going into the future. But it's what's out there now, and we'll deal with that. But we are also developing and have some pumped hydro storage as well, which provides a great way to regulate some of those resources. And we are looking at building additional pump storage. But there's some great technologies out there in the future as well, whether it's thermal mass storage, which is making, I think, a lot of inroads. Hydrogen, if you think of hydrogen as a storage technology as well, I think there's a lot of opportunities.
Excellent. Susan.
Yeah, great question. And just to add to what Mike shared, because he really nailed it. Our transition to clean energy includes, a significant investment in energy storage. So just to get to that 80% reduction, we need 1,400 megawatts of energy storage. So, short term, we're looking at that lithium-ion battery technology. Mike's got a great resource with that pumped hydro storage, right? That's an old technology that serves a great purpose, and I think will make a significant difference because it can be more of a long-term dispatchable resource. And then Mike mentioned hydrogen. So we're talking about potentially adding new natural gas generation to the Arizona generation mix. But long term, I think we're hoping that we can transition those to hydrogen fuel, and we'll start working with a blend initially, and there's some projects that are going on now to start testing that technology. But I think long term, to really get to that last 20%, to get to net zero, I think hydrogen is going to play a big part of decarbonization. So, and I think just talking about other battery technologies, we're looking at at some of the salt solutions. And I know, David, you've got some folks on your team that are doing some research in that space. And, we've got a lot of real estate where we're closing down these coal plants and the transmission's already there. So I think that's a great opportunity to kind of use what we already have and maybe repurpose it.
That's great. I think Susie, you just answered one question from the chat just a moment ago about shutting down some of these coal plants that you just said, shut down, not sell them. You're shutting them down and or will repurpose them. Is that correct?
That's true. And I'll just qualify that, we are a partial owner at San Juan and we're not the operator. So we are closing actually the units that we own in June of this year. And then the Springerville plant, we own half of it and operate all of it. But Tri-State and SRP own the other 2 units. And so we can only commit to what our time frame is, but our plan is to close our 2 units by 2032.
Good. I know it's excitement around hydrogen. There's going to be the Department of Energy is looking to fund regional hydrogen hubs. And I think we have, or we'll be talking probably with both of you. There's a workshop next month up in the Phoenix area that I'll be participating in to talk a little bit about solar-based hydrogen technology. So I think there's a lot of exciting opportunities. Just stay on storage and renewables for a moment and talk a little bit about the cost and reliability. And I'll say, did we learn anything from the freeze in Texas that I think in the public was often maybe wrongly blamed on renewables? But again, any lessons that we've learned from that, I'll ask you to both talk about that.
Sure, I'll throw out a couple comments to start with. I think it's easier these days to compare renewables versus traditional fossil fuel because we have a little more experience with it. And we used to really have to make that balance. And do you want to go with the renewable technology at a higher cost? And we would try to balance that. Now with costs where they are with renewables, those decisions are different. Now it's one, how much renewable can you put on and still be reliable? So it shifted that argument away. And I think ultimately it's going to be a very reliable system, but we can't get there overnight. Really, as much as we all want to move that direction, when you think about battery storage and some of the solar technologies, it's still fairly nascent technology. And we don't know if we're going to get 10 years of life or 20 years of life. We don't know if we're going to see degradation in the output curves happen in 3 years or 5 years. So we're a little bit betting on the future here. And I think we're all in, but there's still some questions on the reliability side of that. I think we're going to have to work through. I agree absolutely with your statement, David. Texas was not a renewable problem. The freeze in Texas impacted renewable systems. It impacted natural gas systems. It impacted transmission systems. And it highlighted a number of inefficiencies in the system, the way it was designed and operated, and the market, the way the market was structured there. But it should not be taken as a testament that renewables are a bad thing, even though it was used that way.
I'm glad I wanted to give you a chance to clarify that record. Susan, you want to, and I think it's interesting your point of this sort of inflection point from cost to reliability and integration. I think that's really nice for our audience to hear, particularly our students that are joining us. Susan.
Yeah, I think, agree, of course, with what Mike's sharing. And I think the story in Texas also is about the interconnectedness of the grid. So as they were losing resources, they didn't have the ability to kind of pull in from neighboring states. And that's one of the benefits that, SRP and TEP and UES, we're connected to 14 states in the West. And so we have access to power, from far away, which is really helps us maintain our reliability. We're actually just getting ready to join the California ISO's energy imbalance market, which does trading on a 5-minute increment. And that's really designed to maintain reliability as we increase our renewables. So I think that's a great resource that we have here in Arizona. Yeah, I think that's going to continue to grow. I think we're continuing to look at our markets and figure out how we can get the most value out of all of the resources that we have available. Just another thing, I think with Mike mentioned it, we're regulated monopoly here in Arizona. Both in California and in Texas, you see retail competition, and that can there's obviously benefits and costs associated with that. And in normal markets, customers tend to benefit for pricing, that competitive pricing. But when it comes to these extreme events, and Mike talked about it, like we're committed to reliability here, right? And so we're not cutting costs to make sure that we can be competitive. We're looking at kind of that sustainable grid that's going to be available. And that's why we have such high reliability here in Arizona.
No, I totally agree. I think buying power, on the spot market as a consumer, when there's some lulls in the prices is great when it works. But as you said, Susan, when there's suddenly a demand that's not being met, then people got those $10,000 electric bills and they didn't like that, right?
I guess not. Yeah.
Absolutely. I think
David,
go ahead,
if I
please.
make one more comment about that, what has helped utilities for years is having very diverse generation portfolios. So having gas, coal, nuclear, solar, and market as one of those resources. As we shrink the fossil fuel resources and end up with more solar and relying on the market, you start to expose utility customers to systemic risks that you just can't diversify away by additional manufacturers. So that's going to get more and more problematic going forward as well. And that's just something that we're going to have to think through.
I agree. There's a fairly highly referenced paper out there that talks about the energy wedges, and basically that ultimately moving forward, it's going to be the same philosophy, Mike. A number of technologies to wedge by wedge solve the sort of sustainability, renewable storage problems. And that's what it is going to take. And that does give you that resiliency, right? If one should fall down. You've both hinted at it, but again, it was a question asked, what do you see the next decade of the energy profiles in Tucson and Phoenix? I think you've hinted at this, but I'll just ask you to maybe give a quick summary.
Sure, I'll jump in. First starting with kind of where we've been over the last 10 years. I mentioned that we just added the 450 megawatts of renewables last year, and that doubled our resources. So pretty significant shift even just in the last year. And then over the next 15 years, needing to add 2,000 megawatts of renewables, 1,400 megawatts of energy storage. But that only gets us to, what we talked about, that 80%. So still looking at new technologies to really get to that net zero. But I think also looking at our load curve, it's changed significantly. So we used to see a peak in the middle of the day, right, when everybody's cranking up their air conditioners. But now with solar being at its highest output in the middle of the day, we're actually seeing sometimes even a negative peak. So we're actually generating more than it's being used. We had a day in March where we had over 100% of our load. So we were actually generating more renewables than we had load for. So we were obviously selling it into the market. That's a new one for us, right? So and that kind of brings back to Mike's point about we have to operate the grid in a new way here. And so I think a big part of it, we're also seeing a shift to electric vehicles. And so, this won't happen here, but in the East Coast, the electric vehicle manufacturers recommend preheating their vehicles, when it's cold out. And so you're going to see a new peak in the morning that we've never seen because everybody's charging up their car before they go to work. So I think there's an opportunity here for us to shape the curve, though, and really incentivize EV owners to charge in that super off peak when the rest of the loads have come down.
Yep. And again, opportunities for storage, right? If you can store that solar in the day and use it to charge at 3 a.m, that would be a great solution.
Yeah, and those vehicles are actually little batteries running around, right? We have a couple of island companies in the Fortis family, and they're looking at, can we use school buses or city buses that are electric vehicles to, in an emergency situation, that's a battery that you can connect to the grid and use that energy.
Absolutely. Great stuff. So I'm going to transition lots of questions pre-submitted in real time about nuclear power. Now, Susan, I know that TEP doesn't have a nuclear power plant now, but you can also comment from your perspective of Fortis, and do you have those in your portfolio elsewhere? And what are some future plans? So I'm going to start with the question about, several have asked the prospects of small nuclear power plants for baseload, and the move for these kind of mini nuclear plants, similar to the power plant, for example, on a naval ship that's nuclear powered. So those are small scale reactors. So, I'll start with you, Mike. Any interest in sort of small nuclear technology for peak loads and things like that?
Yeah, absolutely. I think I think small modular reactors have a great future. And I think we're seeing some applications of those now in demonstration projects. And depending on the success of those, I think we'll start to see it in the industry. Putting in nuclear power is a challenge with new technology, because you have to go through what's called a design certification, then engineering certifications, construction, siting processes. That process takes a decade to get through. So it's a long process from start to finish of a new reactor, of how you do that. But we're seeing some of them start to move through that process, and I think there's a good future for it. I will tell you, there is not a larger source of carbon-free energy in this country right now than nuclear energy. And it provides good, solid, reliable baseload generation while not generating any carbon. So not to consider that as part of the future as we all think about decarbonizing our portfolios would just be remiss. And I think we need to focus on it. So there's some great new technologies that we're seeing, some more of them being discussed in the next generation of nuclear reactors. But if we can perfect the idea of putting in modular units of 50 megawatts, 200 megawatts, something besides 4,000 megawatts, then I think that opens it up to more utilities. The truth of the matter is, to build a plant the size of Palo Verde takes cooperation from lots of utilities and partners to do that. And there are very few utilities that have a balance sheet that can support that. And we saw that recently with 2 utilities essentially going under as a result of failure of development of a nuclear plant. So it's a different environment than it was in the 70s and 80s when so many of these got built. Focus is shorter in terms of time horizon as opposed to a 10-year. So somebody who's going to commit 20, $30 billion to a project like that are going to be few and far between.
Wow. Susan, does Fortis have a nuclear portfolio? And is that something that in your more senior discussions among the company look to invest in and or participate in?
Yeah, we don't currently have any nuclear in our portfolio. And it's hard to add to what, the professor from MIT has to say here on nuclear, but I'll just share, too, that, Mike is always the first to bring up water issues. And so I think that's always a concern. Nuclear, it uses the highest amount of water per megawatt hour. But I think, Mike, we're seeing a lot of movement on the federal government side in trying to tackle some of these siting issues. I think they're trying to come up with a shorter process. You still have public perception of, hopefully y'all have seen the Netflix series on Chernobyl. It's fantastic.
Yeah.
But, people, that sticks in people's minds, right? But you see Germany is looking at restarting some of their nuclear stations that have been shut down. So it's a really important resource, and I hope to see it really gain some traction in the next few years.
And I think, geopolitics quickly spills into energy, but you're right. Germany shut down a lot of nuclear power. And now with Russian energy and coal and gas, suddenly you're right. Was that premature? Let's stay on nuclear for a minute. And Mike, kind of back to you with the Palo Verde station. Where would we be as a state without that? And you kind of hinted at it, but do you perhaps see other large scale plants on the horizon, those $20 or $30 billion investments?
Yeah, we obviously, without it, we'd have taken some other steps and been ready for it. But if you took it out of the portfolio today, it would have a huge impact. It's just short of 4,000 megawatts of capacity. And it's 24/7. I mean, that unit runs at 95+% capacity factor, which means it's never down. That's a lot of energy. So that provides solid base load response to what the loads we have out there are. The issue is going to be, as Susan described earlier, as our load shapes change, what do you do with a resource that is ineffective varying the output of it. Nuclear runs best when you open the throttle all the way up and let it run. And you can't really fluctuate the output of that. So how do you use the output of nuclear when it's not meeting retail load to generate hydrogen or to supply thermal storage or do something like that? So can you take a large nuclear power plant like Palo Verde and help it enable storage in the electric utility industry? And to me, that's an exciting opportunity.
Yeah, I think that opens opportunities like in non-peak hours to use that electricity and electrolysis to make hydrogen from water, right? And now you've got a great energy storage medium that could be used for transportation and or back to peaking. So yeah, so many neat opportunities there. I think it's very exciting. Good. Let's move on to the grid. We've gotten some good questions about that. So just when we talk about the infrastructure of the power grid and the connectivity and the integration of renewables, solar, how do you both see that, and what are the challenges? What are the opportunities? I'll go to you, Susan, and back to Mike.
Sure. Yeah. We tend to build these large scale projects outside of town, right? Because it takes a lot of land. I mean, our Oso Grande wind project up in New Mexico to take you hours to drive across that site. And so it tends to be windy in places where people don't live. Maybe people don't live where it tends to be windy. But so then you've got to bring that power to the customers. And so that interconnection is really key, and transmission lines are really going to be essential. Building new transmission lines to bring those resources to the load centers. And so, I think one of the challenges here is, again, that siting process. It takes years to get a transmission line sited, and God forbid you try to build one in the middle of town. We're working through that right now, but there's some pretty exciting projects that are planned here in Arizona. You've got the Southline project. We're building part of that, the part that goes through Tucson right now, and Sunzia, and both of these are designed to bring wind energy from New Mexico through Arizona, even over to California.
Yeah, I think there's going to have to be some additional transmission to get the most out of renewables. It's just that simple. All the renewables aren't in places where all the load is, and we need to find ways to look at regional diversity as well. So when the sun's not shining in Arizona, is it shining in New Mexico, Colorado, Utah, and how you integrate those systems as well, so you're getting the most efficient use out of those renewables you can. We never had to worry about that with fossil fuels because they were dispatchable, and we pushed a button and they came on. It's different with these renewables, and so you need a bigger footprint to make that work. Regional transmission organizations and markets like the EIM that Susan talked about earlier are ways to do that. But ultimately, you're going to need more steel in the air to make some of that happen. We have extensive transmission networks built to where our remote coal plants are. So as we shut those plants down, how do you take advantage of some of that? And do you think about co-locating renewables where those coal plants are, so when you shut them down, you're not having to rebuild that and you could take advantage of it? So that's going to be really the challenge, I think, over the next dozen years, is how we integrate that from a system perspective. Then when you get farther down in the system, you have it at the distribution level. And are we where we need to be for every customer having electric vehicles, having rooftop solar? Can the distribution system support that? Do you end up with voltage problems at the end of a feeder? So the entire infrastructure is going to have to go through a remake as the system changes. The good news is it doesn't change overnight.
Right.
And so we will make those changes as we are. It's easy for people to be critical of the grid because they like to say that word, but the grid means a lot of different things.
Right.
And it provides very reliable service today. And I think we'll make those changes going forward so it continues to do that.
Good. Susan mentioned difficulties of permitting things like new power lines, high voltage lines, and I'm going to kind of push to a broader issue, because this spills also into things like production of copper. So, suddenly what we have is maybe emerging of sides that want to have sustainability, want to reduce carbon emissions. So we need more copper for electric vehicles. We need more transmission lines for our renewable energies. Do we have an opportunity to, bring sides together that have been historically maybe opposed to, I don't want that transmission line from the coal plant, but wow, from your wind plant, maybe I'm a little more open to negotiations. Are we entering a new era of maybe, I'm thinking big here, positively, of cooperation between groups that haven't maybe historically wanted to work together? Are you starting to see that door open?
I hope so. But the environment right now at large doesn't make that very easy to happen. There's a lot of divisiveness and the economy as a whole today, so it's challenging. We are currently citing a gas plant, as I mentioned earlier, to help facilitate renewables. And there is a lot of opposition to that because it is a gas plant. And stakeholders who are really focused on one issue, whether that issue is carbon, whether the issue is cost, whether it's reliability, pick your issue.
Right.
They have the luxury of not caring about the rest of it. Or I shouldn't say not caring, not having to do anything about the rest of it. So they can advocate no gas at any expense or no cost. Don't raise our rates $1 because they don't have to worry about the impacts. We do. We have to balance those. Susan mentioned the stakeholder process they went through earlier. And to me, that's how we get there. We start bringing those people in. We help with the education of both us and them and try to understand all issues of it. And if we get to a solution where nobody's happy, it's probably the right one at the end of the day.
Very nice. Susan, what are your thoughts? Are you seeing some opportunities here?
Yeah, for sure. And, and I keep going back to what's happening on the national level. Our current president's very committed to a green grid. And so like Secretary Granholm, the Secretary of Energy, she's very engaged with our industry and really mindful and listening to what our issues are and concerns. Gina McCarthy, who's the White House, I don't know, she's like the environmental advisor, came from the EPA. She's super engaged and helping us kind of solve these problems nationally. But when it comes down to it, like Mike said, it's all about not in my backyard, right? So we've got to, I think, help our stakeholders see the big picture and realize that there are trade-offs that you need to pick what's the highest priority. And I love how Mike, I love how you said that. If no one wins, I think we've found that right sweet spot.
Sure. And, in this day and age, my backyard is the entire planet, right? And so we need those solutions. This is great. So I'm going to kind of change gears and talk a little bit about, your roles as utility company CEOs and some broader questions. My own daughter is a entry-level engineer in the utility industry. So what advice might you have for young engineers or engineering students that are interested in a career in the utility industry? I'll go with you, Susan, and Mike.
Sure. Yeah. I always encourage students and new grads to just stay curious, think about kind of learning what you're responsible for in your new job, but also kind of how your job fits into everything else, right? Because it's understanding that big picture really makes you better at what you do. And I think specific to our industry, we're not really known for being fast to change, and yet we're facing a really big challenge here that we need to change more quickly than we ever have. So we're looking for those change agents, those change leaders. And I think what's great about the students that are coming out of the universities now, they're really tooled for innovation. And I think that's the perspective that we need to bring. And that starts from just looking for little things of how do we do what we do better, to really big new solutions like how do we get to multi-day storage. And then lastly, I'll just say, Dean Hahn, if you want to send your daughter's resume, we'd love to recruit her.
I love her back in the state. She's a Wildcat engineering graduate student as well right now. So yeah, I'll keep that in mind, Susan. I do hold you up as a role model to the young women in engineering. So thank you for that.
Thank you.
Mike.
We have a spot for her for sure.
Fantastic. Mike.
Yeah, Susan said it very well. I think The interesting thing about the utility industry is the pace of change right now. And when I came out of electrical engineering at U of A years ago, you looked at how the person before you did it for the last 30 years, and that's what you did. And it didn't change very much. And it was a bit of a staid environment. It's not that anymore. And we have far more questions than we have answers. And we need creative, innovative people to help solve those. When I look at the new engineering students that are coming out today, I see those that, as Susan said, are tooled to be innovative, but also far more multidisciplined, which is critical. I mean, a utility company, we're an electrical engineering company, we're a civil company, we're a nuclear company, we're a mechanical company, we're an accounting company, we're everything in between there. And so we need people who understand the breadth of how you apply those decisions and impacts across the organization. And what I've always valued about an engineering education is the number one attribute is it teaches you how to solve problems, not necessarily how to solve electrical problems, but how to solve problems. Absolutely. And that's exactly what we need in this industry today. And so I would encourage people to consider an electric utility future as part of their career and bring your best to it because we need it.
I appreciate your advice to all young students. As I open this up, energy will be in our lifetimes remain one of our great societal challenges and issues and hopefully solutions. Just quickly, what has been maybe what you consider one of your most satisfying accomplishments in your career? And I'll go to you, Mike, and then back to Susan.
Right. I think everybody gets to some point in their career where the most value they get is seeing people around them develop and putting people in positions where they can grow and learn and be successful. And I would say for me, that's the most satisfying we have. I have such a strong staff. Many are U of A engineering graduates, by the way, and folks under them that are getting new opportunities every day and doing great things. And that's really rewarding.
That's wonderful. Susan.
Yeah, kind of a similar response. I inherited a really well-run company, and so we have a great strategy. I think we have the talent to execute. But when I think about what success really looks like, I define it in terms of not only what we accomplish, but how we accomplish it. How do people feel about the work that they do? Do people feel at work like they're valued, respected, and heard? And so I'd say what's an accomplishment around that? Well, we've established some business resource groups like Women in Energy, a group for veterans, an LGBTQT group. And so just making sure that we're supporting the diversity that is within our company and making sure that we have an environment that's inclusive where people feel like they can be their best every day.
That's wonderful. I can't let it pass. You said you inherited a well-run company from another Wildcat engineer.
That's right.
So.
That's right. Another two-time grad. Yeah.
Very proud of that. Those are really, thank you for sharing that. This is going so fast. I'm going to try to get in two more questions. I'll go kind of one to you, Mike, and one to Susan next. So Mike, SRP isn't just an energy provider, which we focus on, but you manage this 13,000 square mile watershed, which I had an amazing tour of with you. It's fantastic what you do. Want to share just some thoughts about, the future of water to the Phoenix area and Tucson area? I know you don't provide that, but CAP flows right through your area, and talk a little bit about water.
Yeah, it's obviously getting a lot of press over the last couple of years for not a good reason, because it's challenging right now. We have been in an extended drought in Arizona well over 20 years. And when you look at tree ring data that, by the way, U of A helps us do that research, you can go back to the 1300s and not see this kind of history. So it's significant. The good news is it's getting more attention, and there are resources that can be brought to bear to find solutions for it. People need to understand that water is a limited quantity in a desert. And we've not had to face that really before, but we are right now. The Central Arizona Project, which brings water from the Colorado River through Phoenix area and then down to Tucson, provides about 40% of the water to the state of Arizona. And the Colorado River is extremely challenged. Lake Mead and Lake Powell are at their lowest level since those dams were built, and they're not going up. And the latest projections for the next 24 months suggest we could be in for some more cuts there. So that's going to be important for people to think about. Really, three elements when you think about water management in the future. Conservation has to be at the top of everybody's mind. Reuse of water, whether it's effluent or rainwater, or ultimately recycling all water, which means taking toilet to tap and getting rid of the yuck factor with that and realizing you can treat it. And other countries do, and that's got to be part of our future. And then augmentation, whether it's desalination from the Gulf or somewhere else, and bring additional water supplies to Arizona. The governor has committed funds to it, and he is creating there's legislation to create an organization called the Arizona Water Authority that will begin to help find some of these solutions, and it's a good start.
Excellent. Very, very good. And we appreciate that stewardship of water. Susan, just I'm going to probably wrap up with you. We've talked a little bit about natural gas, its role in peaking. I know both of you're investing in some natural gas, Mike, to handle load shifts. Susan, you guys opened a few combustion natural gas plants, right, fairly recently to handle peak loads. It's a vital part of managing renewables. It's also, of all combustion, it's certainly the most cleanest. So, Susan, how do you see natural gas in the utility portfolio for the next kind of decade or so?
Yeah, I really think that natural gas generation is kind of the bridge to renewables. And, we have some reciprocating engines that we installed, just went live with them at the end of 2019. And honestly, they start up like a car, like literally they're online within 5 minutes, and you can ramp up and down super quickly. So they're the most flexible units that we have in our fleet. And that's really what you need to offset the intermittency of renewable generation. So I think that these are long-term solutions that, to me, the only thing that's going to make them they'll not go away, but they'll transition to a hydrogen fuel. And that's how we make them cleaner. But even just the transition to those reciprocating engines, we reduced our water usage by 70%.
Wow.
So they are the cleanest, but they also use the least amount of water. And I think that's an important part of our transition.
That is fantastic. This has been a wonderful discussion. I'll give you each just, a few closing words. Again, I just want to express my gratitude. This has been a very engaging discussion. Again, energy is such an important part of everything that we're trying to do. And it's a very dynamic time. So we again appreciate your stewardship of your companies to provide the people of Arizona that reliable, sustainable, and affordable power. Mike, any kind of parting words from your side?
Well, I would just, again, thank you, Dean, and to the college for doing this. And hopefully we were able to communicate that there are immense technical challenges we're going to be facing. And programs like yours are where we're going to be looking to bring that resource out of. So we appreciate the attendance today and the participation, because I think people are going to have a great future in the electric utility industry.
We welcome that partnership. Susan.
Yeah, this has been great. I'm so glad to get to be part of this. But, David, I really appreciate that you've acknowledged that this is a huge issue, not just in Arizona, but in the world, right?
Absolutely.
You can't do anything without energy. All of our essential services run on what we provide. And I'm just so appreciative of the partnership that, being part of this hydrogen hub, even the research that you're doing on new battery technology is really important. And so I'm excited to kind of continue partnering with you, but also for the types of students that you're turning out, I think are going to be perfect for what's really become one of the most exciting industries in our country. So we're recruiting and love to hear from some of your students.
Fantastic. Well, it has been a delight to spend an hour with both of you. I know you're busy keeping that reliability and sustainability going every day, but it's been great to have two of our Wildcat alums come home for an hour and spend a little time with us. And I just, on behalf of the college, I know both of you are really committed to helping and partnering, and you give so much back. So thank you. With that, I want to thank our audience members for joining us and wish everybody a wonderful afternoon. Thanks all. Bye, Susan. Bye, Mike.
Thank you.
Bye,
Thank you.
everyone. Take care.